Assalamu alaikum. My name is Abdullah Jabal and today I will be explaining lab number 3 of microcontrollers and embedded systems. So basically in lab number 3 we are going to implement simple codes using C language, and further down the road we are going to implement a 7 segment display and make a counter through it. So basically we are using a C language, which is topmost language used in most of the application now. Using it can be also used using Arduino and as well as Avia Studio. So now let us move towards the lab number 3 introduction. So we will first search for navigation. So we will in this lab we will see how 77 works with and without hex keypad. So with hex keypad we will see in lab number 4, and without hex keypad making a counter we will see it in here. So basically what we are the operation that we are going to perform is the first of all we will see what is 7 segment display. 7 segment display is a set of 7 bar shaped LEDs arranged in a square forms. 7 segment LEDs are represent alphabet from A to H as shown. H is represented by a dot. To turn off the specific LED we must put specific binary code. Application. So basic the application of 7 segment displays are that they are used in digital clocks, radio transmitters, timers and wristwatches. So there are two basic types, common cathode and common anode. So basically according to this diagram we can configure the LED to display any value from 0 to FF. So what is common there are there are two types. One is common cathode and common anode. So one is illuminated by a high logic signal and other is illuminated by low logic signal or ground signal. So first we have few example. 7.1 we write the program to send 0f00 to 4 to 0fff to port B. So we are making a particular counter that will display value from 0 to 20 to 55 on the port B. So now let us move towards it. So this is example 1 of our lab 3. This is a particular AVR code. So this is the code. We have declared our port B as output, and we have made a loop that is incrementing the value of variable 0 from 0 to 255, and we are displaying that value on port C. Now let us move towards the Brody simulation of example number 1. Upload the code. So it will display the values from 0 to 255 on our LEDs. Wrong X file is uploaded. So as we can see, our LEDs are blinking. So for further, we have to add a resistor. As we can see, these LEDs these points are blinking, so it is continuously changing its value. So now let us move towards the second code. In the second code, what we are doing, In the second example, we are sending hex values of 0 to 0 1 2 3 4 5 A B C D to port B. So we have not created a particular proto simulation file. We have only created a avia studio file. So we can see that avia studio file here. So this is a AVR code in which we have declared an characters type array 0 1 2 3 4 5 ABCD, and then we are displaying that code with delay of 1000 millisecond or 1 second and displaying it on port B as output. So we have included a display delay library using hashtag define FCPU 16000. This 16000 is the clock of the particular microcontroller. So we are using this clock to use a built-in delay library for our particular delay function. Now let us move towards example number 3. So what we have done in example number 3 is a build program to toggle all the bits of port B 200 times. So we are toggling the bits of port B 200 times, so that it means that we are making it 0xAA and 0xFF. So it is example number 3. Now we will upload the code for example number 3. Code for example number 3. 3. So it will take some time to run this. So this is now toggling the bits of port number B simultaneously. It is making 0xFF and it is making 0xAA. So now let us move towards example number 4. So what we are doing in next example, we are getting a byte of data from port B and sending it to port C. So this will be this example. So basically let's upload the code. So we will upload the code first. Downloads lab 3 example 710. So now it will display whatever the value is given to it on the output. So let me change the value. As we are changing the value on the input side, the value is also changing on the output side. The AVR code is given below. The example, we are taking input from one of the ports and we declared the other port as out. And the input value is given to that particular port whenever we give the input. Now we will move towards the next example. In the next example, we have used simple and this simulation. So we have ran this simulation down here, and we are performing just simple functions that include and, or, and XOR operations. Now we have example 7.14. A program to bit monitor bit 5 ports. If it is I send 55 to port B, otherwise send AA to port B. So this is example number uh, 14. So it is also given here. We have simulated it properly. Now we will move towards task number 1, that takes input from port B, check whether it is even or odd, and then according to it, it will display the values on output port. And the final we have example number task number 2, which monitor port bit 5 of port C and high is and send it to port 55 and port B, otherwise send A. So basically the last 7.12 and task 2 are same, so we have simulated it collectively. So this is first example number 1, that will check for even and odd. So first of all we'll edit properties and upload this downloads lab 3 task 1 debug and task1.x. We have added the x file. Now we will simulate and check it for even and odd. So basically first of all we are giving it an even number. So for even number it will follow this sequence, and when we will give it an odd number, so let us check for an odd number. So when we give it an odd number, it will glow from this side and keep on glowing from till that. So this is a simulation for checking even and odd. So now let us move towards uh, next part in which we have to check for the final. So first of all we will upload the hex file into it, edit properties, and now we will look at the particular hex file. Particular hex file is downloads lab 3 ex- task number 3, and so basically move back with task number 2 pb, and we will lab open. Okay, so basically it is giving this value and checking the bit number 5. So basically on based on this bit it is giving the values of toggling on our output value. So now let us move towards the final simulation, which is for the 7 segment display. So now let us move towards the code of the 7 segment display. Um, so we have made a counter using 7 segment display for this final example for our code. So this is the code for 7 segment display making counter. So basically this is a simple declaration of the output port for the both. This is a declaration for the compare values to display the particular combination of 8 bits on our 7 segment display, so that it can display the particular number 1 2 3 4 so on. So this is a loop which will run and count until 255 is reached. So now let us move towards the PCB, towards the Proteus part. So this is the Proteus part of our PCB. Let us upload the file task 3 counters. Now it will start counting from 0, 1, 2, 3, and up to 255. It will go on. We will watch this counting up to 15. So that's all from my side regarding the protest part. So now let us move towards the videos.
ये हमारी लैब नंबर 3 की एग्जांपल नंबर 1 है। इसके
These
अंदर
are the
हमने
videos. In
फंक्शन
this
बनाया
video,
है
we are discussing
कि
the
हमारे
example number
पास
one
हमने
of
सबसे
our,
पहले अपनी
and it is
DDR-P जो पर्पस
explanation
P
that
मोड है
where
उसका
the
आउटपुट डिक्लेयर कराया है।
configuration
उसके बाद लूप
DDRP
चलाया जो
P
हमारी
as
0 से लेकर
output, and
255 जो
then the
मैक्सिमम
loop
इनपुट
runs
की
from
वैल्यू है वो
0 to
आउटपुट कराएगा। और अब
255,
पोर्ट सी पे
and the
आउटपुट
output
कराएगा
displayed on
पोर्ट
port
बी पे,
Z.
क्योंकि इसका डिले का फंक्शन नहीं है तो ये क्योंकि वो माइक्रो सेकंड में काम कर रहा है तो डायरेक्टली ये इतनी जल्दी करेगा कि हमें सारी आउटपुट में जो पिन है वो वन वन शो कराएंगे। तो इधर हमारे सर्किट में जैसा कि देख सकते हैं कि अब इस टाइम सारी पिन वन है तो इसका मतलब है कोड पूरा रन हो चुका है और ये अपनी फाइनल आइटरेशन मतलब जीरो एक्स एफ एफ पे पहुंच गया।
So now let us move towards the next video, which is for example 7.9.
एक मिनट, इसको इधर से ग्राउंड करना है, ठीक है, इधर से
And
5
then this
वोल्ट
is
देना है।
example number one. Now let us move towards the next video.
अच्छा, ये हमारा लैब नंबर 3 एग्जांपल नंबर 2 है
This is example
जिसमें
number
हमने
two, which is
एक
displaying
माई
the
लिस्ट
values
बनाया हुआ
of the
है
arrays.
और उसमें 0 1 लगाया हुआ है यहाँ पे माई लिस्ट। इसके बाद हम अर्डिनो के साथ कनेक्शन दिए हुए हैं पोर्ट बी पे, हमने यहाँ पे चल रही
So
है
displaying
ये
the
पहले
particular
0 1
values,
2 3 4 जाएगा और एट
displaying
द
0,
एंड
1, 2, 3,
हमारे
4,
पास
and then
ये
A, B, C, D.
जो हमारे पास है 0 1 0 0 0
And then it
1 0
starts
0
all over
जो
from
कि
ever
44
again.
है डी का, तो
And
वो
let us move towards the next video. This is example 7.2. This is a clearer video of the previous example. And let us
भी
go
हमारे
to
पास
example
एग्जांपल नंबर
number
3
3.
लैब 3 है और ये हमारे पास इसमें हमारे पास दो
That
सौ
is
बार
the
लूप चलेगा
toggling of
और
the bit
इसमें
of
हमारे पास
the bits of
पहले एक
port B.
आउटपुट लेंगे जो हमारे पास जीरो, इसको हम इसका कॉम्प्लीमेंट लेंगे। हार्डवेयर पे आ जाते हैं, उसमें हमारे पास
These are the
दो सौ
this
बार
is the
ये
toggling of the
चलेगा
bits
क्योंकि
of
हमने
port
200
B.
का लूप लगाया हुआ है।
So
ये
now
पहले
let us move towards the next video.
डिले डाल के चलाएं
This
सारे,
is the next video.
वो लैब एक्टिविटी 1 नहीं वो नहीं डलाई हुई।
This is same toggling.
ये हमारे पास है लैब
This is
नंबर 3 एग्जांपल
that we
7.10
will get input which
जो कि
will display the
चौथी एग्जांपल
output
बनती
on
है
the
इस लैब की, ठीक है।
next port.
हमारे पास इसमें हमारे क्या है कि हमने इनपुट सेट की हुई है वो यहाँ से 1 1
The
0 0
input
0
is
0
set during
और
this
फिर यहाँ पे
register
अगर हम
using the
देखें
system,
हमारे
and
आउटपुट पे आप
whatever
देख
the
सकते हो
value
1
is
1
given,
और
then
फिर
it will
4
give that
टाइम
on
0 जो है
output.
वो हमारे पास आ गई है। अब हम चेंज कर रहे
Now
हैं
if we
वैल्यू।
change the value, now when the value is changed, now it will give that particular value on the output.
अच्छा, अब हमने वैल्यू इसके अंदर हम सबसे पहले कोड एक्सप्लेन कर रहे हैं। ये कोड है
So
कि
this
अगर
is the
हमारे पास हमारी
this is
पिन
checking of
सी
the
की जो
even and
बिट
odd
नंबर
function. This is task number one.
और पोर्ट डी पे जीरो नहीं है, अगर वो लो है पोर्ट डी के ऊपर। अब हम
So
काउंट
it will
करते हैं
display the
तो
particular
जिस
sequence
तरह हम
based
इस
on
टाइम
the
देख
even
सकते
and
हैं
odd
कि
parity.
अभी इस टाइम हमारे पास ये जो हमारी पोर्ट है ये लो के ऊपर, ये लो के ऊपर है तो हमारे पास पोर्ट बी के ऊपर 0 0 आ रहा है और पोर्ट डी के
So
ऊपर
when
0
it
एक्स
is
ए आ रहा है,
even,
ठीक है। अब हम इसको चेंज करते हैं और
when
इसको
it
हाई
is
कराते
even,
हैं।
when we will make it odd.
ये हाई होगी।
Now we have
अब
made this
जैसे देख
port
सकते हैं ये
high, and now
पोर्ट
the
बी के
values
ऊपर
have
उसने
changed on the next port.
जीरो एक्स पोर्ट डी को जीरो एक्स
So
जीरो
now
जीरो
let
दे
us
दिया
move to
पोर्ट।
the next video.
टाइम अब हमारा सर्किट खड़ा है हमारे पास, इस टाइम हमारा सर्किट जो है उसके ऊपर हमने जो नंबर दिया है वो है हमारे पास एक ऑड वैल्यू नंबर। अगर हम
This is
इसको रीसेट करते हैं, अब ये हमारे पास हमारा लैब नंबर 3 टास्क नंबर 1 है। इसके अंदर हमने इवन और ऑड डिटेक्टर बनाना है। अगर हमारे पास दोनों केसेस में चले लीस्ट सिग्नल से मोस्ट सिग्नल, अब हम मोस्ट की तरफ इस टाइम अब हमारा सर्किट
So now this is the task for the 7 segment display, that we have made a counter using 7 segment display. So this counter counts from 0 to 250, 0 to 19, and then resets again. So that's for all from my side. Thank you for watching.